Yeah, have you guys heard of black pen, red pen?
Shit, of course it's all out of my head now. There's a couple of really cool ones. Um, but if I were you, if you haven't done this yet, I'm pretty sure I talked about this before, you should go to YouTube, type in like Laplacian transform. Watch a few videos, find somebody who makes sense, go to their channel, see what other shit they got, right? And like, for example, I always like to tell people, MIT's got his full course load up in YouTube. It's insane. And they, of course, have the giant chalkboards that I'm so freaking, I miss my chalkboards. The giant chalkboard just surrounding, and then you can move it up and down. And stuff. Anyway, all right. Has anyone tried to Google differential equations calculator or solver? Did you even know you could? So let me show you. I'm always curious what you guys are trying to do. All right, let's see if I can find it. Oh, I already, that's right, I have it. Let me go back. Oh, by the way, so here it is. So if I go to, somebody remember that equation. Let me see if I can remember it. Just to show you. So I just did differential equation calculator. First one. And then I think it was y double prime minus x squared y equals 0. Look at that shit! Gaze upon that. You can't. Let me zoom in a bit. So, just, alright. I don't have to tell you about this kind of shit. I just want to tell you. I'm always surprised that people don't look for that. I'm not saying go here and this is, obviously this doesn't show you the steps. So I don't care that you know about this. This is a beautiful way to check your work, right? Back in my day, we did every damn thing we could to find help. There was a book called REA. It's this massive book with just problems. That's what got me through quantum mechanics, was the REA quantum mechanic problem solver. It's just problem after problem with solutions. It was insane. So I could find one that was sort of like the one I was stuck on and kind of see the steps they took. You know what I mean? Dear God. And now you guys have a stupid amount of holy, you have so many, oh my God. You have the YouTubes. You have the frick, look at this. This didn't exist. Back in my, we didn't know how to do that on a computer. Are you kidding me? No, when I was taking different gear. Way back when. Alright, anyway, sorry. So that's one. There's other ones. This is the first one I kind of found and clicked on. I was like, oh, that's pretty good. It gives a series solution. If you type in a normal, it's not always going to give a series solution, right? This is one that had to have a series solution. But if I just do, just to show you, if I just do this, it'll just give me this, right? You guys with me? Nifty. It assumes it's T, but that's fine. Who cares? I don't care what the letter is. If you put in here, Euler's. Oh yeah, so that's a beautiful one where M is nifty. It'll give you that form, and of course we talked about how to put it into cosine ln x, blah, 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 right? You with me? But that form is still correct. It's just not in the form that we talked about. Are you guys kind of with me? All right, enough of that, I'm sorry. Just to let you know that's out there. I'm always a little surprised if nobody's trying to look for that kind of thing. Because it's stupid, the number of things that, Photomath someday is going to be able to do different view. I haven't checked it, to be honest. Recently it's been able to do a lot more shit. You guys know about Photomath, yes?
Yeah.
Yeah, a lot of students know about it. What they don't seem to understand is it does a lot of shit weird.
Yeah.
So I'm like, that's Photomath. Come on. Come on. Try better. Anyway. All right. You guys know about Reddit cheated math homework? No? You guys know about Reddit? There's cheated math homework. There's, I can't remember, was it on Help Me With Math? I can't remember what the other one was. Anyway, sorry. I'll go in there sometimes and help people out, and I'll be like, in the cheated math homework, I'm like, yeah, you've done it. But, and the other one was like, help me with math, I'll help people with math. Why not? Makes you feel good. Okay, all right, sorry. So, today is all about review. I've got the answer key for the practice test. So it's on you as in terms of what we focus on. So if Nobody's asking a question, the floor is yours. We can focus on, you can have questions for the quiz, you can have questions for homework, you can have general questions like, Jeff, can we do an example of this? And then we'll find one and do it, right? Or, I can just stand here and stare at you. Okay, that's okay. We're just gonna stand here. I brought nothing. Yes, this is reviewing, so it's up to you. 2B. Oh, from the practice. Okay. Here. Oh yeah, okay. I can't remember if I signed one like this in homework. They do an example like this in the book. Did anyone try 2B, or did you look at it and go, he's not going to give us one like that? Screw that problem. Does anyone have a clue how to do 2B?
You convert it into Taylor series.
Yeah. What do you do on 2A? Well, I go to that site you just showed us, and I plug it in there. And I say, I did my work on a napkin, and I lost the napkin.
You should multiply the x to the y, or the x squared to the y.
What's the first step
Convert it to
on
y.
2A? Especially because I kind of gave it away. You assume the form of the answer, yeah?
Yeah.
You y equals the sum of n, cn, x is n, blah, 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 right? You y prime out to the part. Yes? Yes, I did. Totally, exactly. So, just to make sure you understand, the very first thing I'm going to do, I'm sorry, I keep pointing at that monitor because it's the one I can see. Very first thing I'm going to do is I'm going to replace y with a power series, correct? So I'm also going to replace sine x with a power series. And then I'm going to, component by component, brute force multiply that shit out. Not to infinity, but to the first few. So on the actual test, I'll tell you how many terms to go out to. Sort of like I did on the quiz, or I tried to. By the way, if I say the first 6 constants, I mean C0, C1, C2, C3, C4, C5. Yeah. Oh, alright. 2B, I will say this. I wouldn't give you that problem. I might give it to you as a bonus. I have it worked out on the answer key. I wanted to put it down there because they do explain it in the book. I couldn't remember if I signed one like that for homework, but you know, this is a practice test. I don't care. I can make it harder if I want to. So, there was a question earlier about, so let's see. Let's say I do a problem and I get, oh man, all my pens died. It's a weird morning. Stupid. I hate mechanical pencils. Let's say I work something out and I get this relationship, for example. Oh, thank you. Yay! It doesn't matter, Jeff. Just make something up. You can do it, Jeff. Alright, doesn't matter. Okay. So let's see. If n is 0, I'll get C2 equals 2C0, right? If I get n equals 1, I'll get C3 equals 2C1 over 2, I'll get, and then n equals 2. Is everybody with me? This should feel, I'm not going to worry too much because I just made this shit up, but I want to make a point, so let me get a few more down here. I'll get 2C2 over 3. Is everybody with, which is, what's 2C2 over 3? What's C2?
4CO.
Yeah, so it'll be 4CO. 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 The trash computer. Okay, n equals 3. It doesn't matter. Okay. If I go to start, what did I assume the answer was? N equals, what did we always assume the answer looks like? 0 to infinity, Cn, next to the n.
So I've got C2, C3, but I also know C0 is C0, C1 is C1. Those are given. And I call them seeds. So when you have these iterative sequences, you have seeds for them. So like the seeds for the Fibonacci sequence is 1, 1. 1 plus 1 plus 2, 1 plus 2 is 3, blah, blah, blah. Right? You have to have seeds that get you started. There's no way to get the first two ones because there's no numbers before them. So they're sort of like axioms. They're sort of like things I have to assume or things that have to be given to me. So what some people did was they started writing the answer and they said, okay, so C2 is 2CO, so that would be 2x squared plus blah, 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 blah. But you left off your CO. There should be a 1 in here because it should be C0, right? If I make n 0, what do I get? C0. If I make n equal 1, what do I get? Make n 2. So see, if you don't write this 1, you left this term out, and it's part of the answer. From the beginning, you know it was going to be part of the answer, right? And then similarly for the C1, there should be a first thing. So that's why it's not a bad idea, and I totally forgot to do this. I think I used to do this, but write C0 equals C0, C1 equals C1, and then do this shit so that you don't forget that they're there. Right? They get everything going, and they don't get to be in the party at the end. That's not fair. Yeah.
So when you figure out like your constants, you're supposed to go back into what you assume y is, not the new.
Oh, so this is why. All right. You know the form of the solution, so I would always go back to that. I don't do the K thing. And I don't think it should throw you off, because no matter what K is, if you figure out C0, it goes with n equals 0 in the original assumption. Are you with me? C1 would go with n equal 1 in the original, I don't care what you've done in the middle. But I don't do the K thing, because I didn't like it. It doesn't really, it's not mathematically different. It just feels different, and I don't like it. But you can do it, it's fine. Is that all right? So always go back to your assumption of the answer to fill in, because I assume that, I've learned new shit, plug that in. Plug it back in. What did we do when we assumed y equals x to the m? When I got m, I plugged it back in, I got x squared, x cubed, whatever, right? Mm-hmm. Same thing here, exactly the same thing. Once I know what the c's are, I can plug them. Okay. One thing about the problem on your quiz, if you didn't notice that you had to take some terms off, it ended up not affecting you, but it could. So you have to notice when that has to happen. In this case, everybody should have gotten something like 2C2 plus Z0 plus the sum, blah, 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 or 2C2 minus C0. I think this is right? Does anybody know what I'm talking about? You all have your quiz. If you didn't get this, then you don't know what I'm talking about. But you should have gotten to the point where the indices didn't match. Now, real quick, if I have a sum n equals 0 of stuff, plus a sum n equals 2 of stuff, plus a sum of n equals 1 of stuff, and everything is like terms, yes? Which sums do I need to pluck stuff off of? Yeah, I need to take one thing off of this guy, because then it's going to start at 2. And I got to take 2 things off of this guy, because then he's going to start at 2. Some of you guys were taking 2 things off of this guy or something. That doesn't make any sense. Then it goes further into the sequence. And doesn't go down, it goes up. That's all it ever does. Does that make sense? Yes? No. Wait, no, here. You guys know a comedian named Brian Regan? He worked in a restaurant. Somebody said, "Is there any way I can get a glass of water?" He's like, "Oh, boy, there was a way." Yeah.
I never got it.
So here's the really weird thing. Okay. All right. This gets a little weird.
So let's say I have, let me just give an example. Doesn't matter. It doesn't matter, Jeff. Just, it doesn't matter. It doesn't matter, dude. Okay. So traditionally, I would take one out of here. Is that cool? If I take the first term out of here, now n starts at 2. I think what you're asking is, could I do that in reverse here? You sort of can. It's just not always something you could do because this officially does not exist before 2. But you, I'm not sure I answered that question without getting all things a little weird. That'll work most of the time, to be honest, but sometimes it won't, so it's weird.
Unless, like,
If you go back in time and it makes something undefined or something, it's an obvious place it doesn't work. But there are some places that it's less obvious that it doesn't work. Does it make sense? If I go back a step, and the end I start with makes the inside undefined, that's an obvious thing I can't do it then. Yeah. There are situations that are not as obvious, where, I'm not even sure if everybody's really with me, but, so instead of taking the first term off the first, I'm sorry, I keep pointing at that monitor. The first term off the first guy, what Isabel is talking about is, what if I make this go back to 1, and then subtract that extra term I just came up with, right? That, most of the time, would actually work. Sometimes it won't. Especially, like, if I create in 1 over x situation, that's obviously not good. That's another situation that's obviously not a good thing to do. Does that make sense? But I love the question. I love that kind of, that's exactly the kind of thing that I did try to do. Right? So why can't I just go with the other? Especially when you have, like, instead of taking 2 terms off, why not just attack the one guy and make him go forward? Yeah? Okay. Yes?
So when we have the like terms, so like power, so like x to the n, x to the n. When
Yes.
we have that, should we look for like the highest n equals number?
The lowest, actually. If I take the first term off of here, the first term corresponds to n equals 1, correct? Right? What's the second term correspond to?
Well, for like this one, I did n equals 2 and then n equals 1 and n equals 0.
Okay.
No, wait. And then once I got all the same n
X to the n's. Sure.
it's n equals 1, n equals 1, n equals, oh sorry, n equals 0, n equals 1, and n equals 0.
Yes, good, good. Everybody should have ended up like this unless you did really nifty things.
And then
You find the lowest ones and you take the first term off of those because then they'll both start at 1.
Well, what I meant is I looked for the highest number, which is 1, and then turned everyone else to the highest one.
Yeah, which means the only way you can make this start at 1 is if you take the first term off. If I, guys, real quick, if I have this, right, stuff, I do not want to shift the n, because then these won't be like terms anymore. The only way to make the n's match up is if I take the first term off of these two. If I take the 0th term off of this, now it's going to start at 1.
Oh, and we do that by plugging in the 0.
So let's see. If I have sum n equals 0, n plus 2, well, let's make this, screw it, cn plus 1 x to the n. What is the 0th term? Everybody, what's the 0th term here? 2, c, 1, x to the 0, yes? So what's the rest of it now? 1, of course, right? So if you do that with these two, they'll both be n equals 1. And then it'll match with this guy, and you can put them all in one big summation. Okay. Now, just to address some things, we discuss primarily the textbook method. I have shown you my own ways of doing certain things. There are so many ways to do almost everything we've done in this class. If you ever have a different way, just show me. Sometimes I'm like, yeah, I did the same damn thing. Or sometimes like, I have no idea, that's neat. You know, and then I steal it and then I teach it later. You guys understand? So you're at the point where if you're not making math your own, that doesn't make sense. You should be at a point where you're like, I'm gonna make this shit work for me. Damn it. Right? So that's the inspiring thing. You work for me. I don't know if you guys really understand. So like, my stupid little thing when I did integrals and I didn't want to change the limits, so I just put them in parentheses to remind me they weren't for u, they were for x. That was my own shit. I made that shit up. My teachers didn't like it. I didn't care. Right? That's not really a great thing, but I won't do that. Because it made sense to me. It made complete sense to me. So you need to start developing your own kind of approaches to things. You don't have to. You stop. Any other questions? You want to look at quiz problems? Do you want to try some problems out from the practice test? Yeah.
So 7.1, the Laplace transformation of 0, which is 0, right?
Yeah, what would happen, I mean, if you try to apply the whole thing,
Okay.
how do you do the Laplace of anything?
You multiply whatever the function by the integral from 0 to some from infinity, and then e to the negative s times t times the function
Yeah.
dt.
So if it was 0, you get 0, yeah.
0. Oh.
I like it. Thank the gods. Because if the Laplacian of 0 is something, that means everything would have some phantom show up, because everything is plus 0. Everything in the universe is plus 0. How many plus zeros? Infinite number. So if the Laplacian of 0 was not 0, that would infinitely suck. Does that make any sense? Because I have plus 0 in everything. So I have to have a plus whatever the Laplacian is forever. Nothing goes anywhere. We live in gates. No. Yeah.
How do you do the Laplacian for like e times sine or something? There were a couple of problems like that.
I'm pretty sure we did an example. So remember this. There might have been some homework that told you to start from the definition of Laplacian,
Yeah.
but I'm almost certain the book does an example, because this was the translation, right? The first translation theorem. Just to show you.
Is it that like you do it?
Where did they do it? Oh yeah, it was in 7.3. So first translation theorem is where you do e to the at. Heaviside is nifty. Heaviside, real quick, I didn't say anything. This is also called a unit step function, but it's also called a heaviside. It's like the way you can turn a function on at a certain point. Okay. So this is multiplying by e to the something, and that's just going to shift it over by. So we kind of proved it for some simple cases. But I can't remember if they showed, I mean, the beautiful thing is, it doesn't change much. Do you remember what we had to do the Laplacian of sine in the first place? I mean, what would that look like?
K over S squared.
No, I mean the integral. Go back to first principles.
E to the negative st.
0 to the infinity, e to the negative st. Synced, I love it. Be succinct. So if I had an e to the at or something in here, right? This would just be that, which I could make this, yes? So if I had to, it's just really the same shit we did before. We have to do by parts twice. It just works exactly the way we did. We did the sync. We did that. We did the by parts. This would be the same exact thing.
Oh, so it's like that thing where you do by parts and then you bring.
By parts twice, you get a like term, you bring it over, divide by 2.
Okay.
Yeah. Or divide, in this case, by whatever the coefficient is. Yeah. I don't think I did the whole thing because it's annoying. We could do that if you want to, for one thing, if you want to. Real quick, is there?
I was wondering if you would look at this because the answer key had a weird thing. It's just the solution. Like I did it in the same way where you basically just plug in a minus a constant for whatever E is times the S kind of formatting, and this is for sine.
Oh, the hyperbolic, yeah.
But the answer key, am I just not breaking this down correct? Because this is what the answer key has. It's the exact same thing.
Interesting. So this Laplacian, oh, e negative t plus t.
Because that's sometimes the answer key.
Yeah, that should just be a translation. They could have written it a different way.
Maybe.
Yeah, what's the Laplacian of hyperbolic sign? How's it written? KHT, I believe.
Instead of positive, right, negative.
Don't forget, I'm going to let you use this.
Yes.
So it's this here. So if I do the Laplace of cinched, I will get 1 over s squared plus 1. So the Laplacian of e to the t should come out to be this, yes. But what they did was they went further. They tried to do partial fractions. So this becomes s squared minus 2s plus 1, so plus 2. Well, that doesn't make any sense because you can't break that down. I'm not sure what they did.
It's confusing.
Yeah, there could be a typo back there. I'd have to look at it. Which problem is that?
35.
35, okay. I don't know, I'll have to remember that somehow to look at that. I agree with you. It's just a translation, yeah. Yes?
I know on like a previous test we had to kind of show the full length of the problem. Like, are there going to be any problems where we have to derive the Laplace transform and then like show it all the way from like 0 to 100?
Wait.
Like, well, like how you just derived that. Will there be a problem where we have to like show our work from how to derive the transform, and then, or can we? Is it going to
Oh,
mostly plug and play?
I could ask you
Yeah.
to just apply the Laplace, the integral transform
Yeah.
to something.
Okay.
It's not to be something crazy.
Okay.
It's just so I see that you remember
That's
what
what
it
I'm
is.
saying,
That's
yeah.
something you guys gotta memorize is the integral e to the negative s t f t dt. I'm not gonna have you make you memorize all of the forms because a really big reason why I'm not gonna do that is because I forgot them and I don't wanna remember them.
So should we know how to get to all? Get to
Huh?
them? We should know how to get to them.
You should know the Laplace transform itself.
Yeah.
Yeah, because I could ask you show me the full Laplace transform of this function.
Okay.
Then you have to do the integral. Yeah. Yeah.
So with the Laplace, are we able to, so I read the text to me that we could take out multiplied constants.
Yes.
Can we also take out e to the t, multiplied e to the t Laplace times sine?
Well, no. What's Laplace is integral dy.
T.
So you can't take out functions of t.
Okay.
You could take out functions of s, take out constants, but you can't take out functions of t. I like it. Yes.
We could do 1A.
Okay. So 1A. So then you assume, of course. Well, I'm sorry. I started to solve it. Does that same problem down there somewhere? No. Okay. Ordinary point or singular point. So what does it have to do first to this? Yeah, divide by x minus 1. Yeah. So is x equals 0 okay? What's not ordinary? 1. But 0 is fine, yes? So that would be ordinary. X equals 1 would be singular because it's not analytic because it doesn't even meet the fundamental thing about being continuous through one. You guys with me? So this idea of analytic is weird. Analytic means the function you can find a Taylor series for it around the point. For most of what we've done, screw analytic, most of what we've done is either going to pass or not pass the basic is a differentiable continuous. This one's not continuous at 1, but it's continuous at 0, so 0 is fine. Does that make sense? Nothing wrong with 0. 0 is ordinary, right? Which problem is 0 not ordinary? B, because when I divide by 2x to figure out what P of x and Q of x are, 1 over 2x is not continuous through 0, so it will be singular there. Remember, by the way, you already know this stuff. Remember with, in general, what's got to be true about the coefficient of the first term of our DE? To be guaranteed that a unique solution exists, it can't be 0 at any point in any interval I'm talking about, because then it's not truly second degree. So that leads into why 0 is a singular point, but it's not the one criterion. It's more to a singular point, but that's an obvious one. Okay. An obvious thing is telling me that something weird's going to happen at that point. Is that right? So to be an ordinary point for us, when you divide by that first coefficient, do I end up with functions that are continuous and differentiable at whatever point I'm talking about, right? Or through whatever point I'm talking about. Is that right? The bigger picture, if I have funkier freaking differential equations, they have to be analytic, which is a little bit more stringent. But for the ones we're looking at, we can just focus on continuous differential.
Yeah, I went down a YouTube rabbit hole and did it.
Yeah, I'm sorry. I should have. I think I said something, but I should have made a finer point. I think I said it a couple times for the ones we're looking at. Yeah, but again, I've said this before. This is like elementary differential equations, which doesn't diminish how hard differential equations is. Don't get me wrong. Every damn thing's got another freaking part 2 to it, at least. Okay. I like that. You sure? Let me do this. Did anyone try out, what was it? It was, shit, let me see which one was. 2C, I think? Oh yeah, 2C. 2C. Did anybody try out 2C? Nobody? Did anybody try out any of these? No, it's okay. You don't have to. Something nifty happens with 2C. Let me do this. I'm gonna give you guys the answer key. Yeah. So let me first ask you guys this. How are you guys doing? You guys doing all right? No? What is it that has you the most concerned? Huh?
I just don't like the first part of 1 and 2. I just don't like the but I'm practicing.
Understood. Ordinary versus singular. It really is exactly what we just said. For the functions we're looking at, it really is a continuous differential. Of course, you got to remember to divide by the first 2. We've done that a lot in this class. Get P of x and Q of x. Same thing. Whatever you get is a continuous and differentiable through that point, right? You guys got it? So I gave an example of if I had y double prime plus the square root of x minus 1 y prime plus x y equals 0. Can you imagine? This would be horrendous, but if the question is x equals 1, is it singular or is it ordinary? What's p of x? Yeah. So is it continuous through at 1? Yes. Is it differentiable at 1? Why not? Because we talked about this before. This is one of my favorite. Because it's continuous, but the minute you take a derivative, that radical actually goes on the bottom. So then it's not, the derivative is not continuous, which is what differentiability is. Differentiability just means the derivative is continuous through that point, right? So of course, when I take the derivative, it's not continuous through one. So therefore, what would one be? Ordinary or singular? Singular.
Anything less than one would be singular, right?
Yeah, well, anything less than one would be not even in the domain of this to begin with. Do you see what I mean? So it wouldn't even be something I'd be considering. That's why this is interesting. One is in the domain of this, but it's singular because the derivative freaks out at one. Does that make sense? If I talk about 0, it's dead on arrival. It's not even a point I could consider.
Yeah. I was thinking if x was negative one.
Well, F equals negative is even deeper into
Still,
shit.
it's
Yeah.
thinking,
Now, could you do differential equations with complex coefficients? Yeah, of course you can, but dear God, that's, don't even worry. So for us, nothing below 1 even makes sense in the first place, right? Okay. But 1 makes sense. 1's fine. Square root of x minus 1 is beautiful at 1. Derivative sucks. That's why it's more interesting. Yeah.
So whenever we're checking for ordinary or singular differential equations, are we supposed to take the derivative every time we check?
Yeah, so it's got to be continuous and differential.
So it's just using that test.
Every time. For p of x and q of x. So be careful. Look, I'm focusing on the middle one, but it could be the last one where there's an issue, right? Yeah. Okay. So don't let that freak you out. The nice thing with that question is it's just one quick observational thing, right? Well, number 2 was the well, yeah, of course, number 2. Especially 2b, I understand. But again, I would give you this on a bonus probably. Right? I've got it worked out on the answer key, which I just said I was going to give you, and I don't seem to be doing that. I'll give it to you in a second. Okay. Blah, 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 blah. Okay. So I'll go ahead and give you the answer key. It's going to take me a moment because there's 3 pages to this thing. So everything I give you is yours. Don't pass it along. Wait, where to start? Over there. Anytime. Anytime. Oh, let me, hold on, I might have said that last time. Okay. You gotta think about this. I think I did. Yeah. Well, one of them I got on a side note. Is it okay? Can't do this good at 7. I wish there was a way I could load this somewhere and just but I definitely think
I said I'm so behind, it's hilarious. I thought you done homework through. Yeah, I just finished 6.2 yesterday, but apparently we're supposed to be at like in the 7s. 7s are not. I just did. I did the first one yesterday, and I did like oh, it's pretty sick. Like, literally just like the first one's like introduction to like the boss. They have you do like a couple of inverses, like just normal ones, and you just change the functions. Oh, okay. It's pretty simple. You can basically just use the. Actually, I did it online. Because at the end of it, you solve some rate with it, it's not too bad. Okay. Yeah. It's kind of like nifty. You gotta like just keep track of every little like tedious thing. That's about it. Yeah. As long as you're like patient with it and don't like get like impatient and start rushing through it. Like I did on the first one. I did that, I break, and I look back and I made a mistake on the first one. And so annoying. That happens to me with the series. The series is tough. It's so tedious. And these problems are just.
Alright, I want to talk about 2C real quick. Just because it's interesting. None of the other problems are anything else. So look at 2C. Here we go. My God. My God. Okay. Oh, the humanity. So 2C. I think I started somewhere else. 2C starts here. All the same normal shit happens, right? All the same normal shit. Blah, 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 blah. You guys with me? The best I've ever taught that. Right? Blah, 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 blah. Then you get here. Huge side note. This is really nifty. And the reason I thought about this, and this kind of is tugging at my memory strings, but I can't remember this. Do you notice Y2? So if you do this problem, Y2 comes out to be a single term because every other constant after that is zero. Which means that if I assume this specific problem, why is it not Cauchy-Euler? This problem is not Cauchy-Euler. Why not? There's one quick thing to tell me. How can I make this problem Cauchy-Euler? What's wrong with it? If I just took these, moved them over one, then it would be perfectly Cauchy-Euler, correct? But do you guys notice how it's sort of Cauchy-Euler-esque in a weird way? So there's no way in hell you should necessarily, and by the way, this is a huge side note, so if you want me to stop at any point, just tell me. But that answer made me think, what happens if I assume y is x to the n? Because I should get n as 1 for one answer. And sure enough, if you do all the algebra, and again, there's no reason I would know ahead of time this would work. It's not Cauchy-Euler. But if I do all the algebra, sure enough, I get m equals 1. Also get m equals x cubed, but that's nothing. That doesn't really mean anything. So then I just did variation of parameters because that's what I do to have fun. Wow, Jeff. Sounds great. So I did all this stuff, and then you get down here and guess, now, you guys, if you wanted to, you could totally do this shit. That's a relatively nice variation of parameters. Really easy-ass derivatives. I think I lost somebody here. Something didn't come for the ride. How did I lose? No, that's right, because what did happen to me here? U double prime x. This should be plus U prime x prime. Yeah, something. Yeah, here, I lost this. Why didn't this come through? That's weird. And then this would be plus 2u prime x prime. I'm not sure what happened to this poor little dude. Anyway, if you work this out, some stuff didn't come through here. You get to this point. Right, variation of parameters, you get to the point where you get u prime, then you have to integrate. Are you guys semi with me? I don't expect you to do all this, but just to show you. How do you think you solve this?
Plug it into series.
You have to use series. So I don't know if you guys are with me at all. I'm not going to make you do this shit, okay? This is just me doing some nifty shit. That answer told me, wait a minute. I should have been able to do this assumption. It should get me somewhere. And sure enough, it gets me to an integral that I would have to use series for anyway. So it made more sense just to do it assuming a series solution. I don't know if you guys are really with me. I'm sorry. Yes?
It's gonna be like a really dumb question, but why isn't it Cauchy-Euler? Because it has the x's.
But they don't match, the degree doesn't match with the order.
Oh,
So the y double prime should have the x squared. Yeah. But the fact that they're sort of still stepping down, I don't know if there's a general way to know you could do the x to the m and it gets you somewhere. I think most of the time would end up with the weird ass interval that you have to do series for anyway, so it's better just to do series from the beginning. But anyway, sorry. It's just something I think that was a side note from when I did the class a million years ago. So it was all a side note. Very sorry, but nobody was asking questions, so I wanted to talk. Anything else from the practice test, the quiz, homework that you want to look at, or you just want to? Yes. I'm sorry. You first. Go ahead.
Can you look at number 5?
Which one?
Number 5.
5? Yeah. So to trade off a little bit, I do want you to remember the Laplace of the derivatives. That's a relatively easy thing to memorize. So if you guys agree with me. So you remember what, so use the Laplace transform. So I want to Laplace transform both sides. This thing you'll know. Does somebody remember what Laplace of e to the t is?
1 over s minus 1.
Yeah, because it's kind of like a translation of 1. 1 is 1 over s, so this will be 1 over s minus 1. How do we do the Laplace transform of the second derivative?
S squared.
Yeah, it's beautiful. It starts off with a second degree, with a second order.
And the big y that.
Big ass y of s.
And then
No parenthesis, you're not an s.
minus s, y naught. Or
Yeah, then it goes down by degree. S, y0. And see how it goes down? Isn't this an integral? That's why it's a big ass y.
Yeah.
Isn't this a derivative in an integral? That's why it's a little y. And then, of course, the next thing should be
Y.
a derivative. So it goes down by degree and then up by derivative. Do you guys see that? I don't know. That's y double prime. Then I've got to do minus the Laplace, minus twice the Laplace of y prime. So it has the same idea, minus 2, first degree because it's a first order, big ass y. Then normally, so let me do it like this. And then it would be minus, so the s goes down by 1 degree, so there's now it's constant. And then this is y of 0. Is that all right? And then plus the Laplace of y, and the Laplace of y is just what? Big ass y of s, yeah. And the other side is 1 over s minus 1. So I want to give you at least one problem where you actually get a number for one of these, because normally a lot of them are zeros. Because it kind of makes sense, a lot of the problems in real life, the initial condition is 0. Not always, but very often. So here's one situation where the slope starts at 5. So I'm going to have to put a 5 there, but the y zeros are just 0. Is that cool? You guys semi with me? Again, so the Laplacian takes a differential equation, transforms it into an algebraic problem. Now, however strong or weak your algebra is will determine how the rest of that problem goes, right? And of course, everybody's favorite thing in the world, partial fractions, will come into play, right? They will. You can try to calculate, but don't do this problem. How many points is this? Yeah. We can finish that out if you want to. Huh? Okay. So like a lot of problems, it's always that first step that, then after that, it's just replacing and then trying to solve for big ass y, right? The nice thing with Laplacian DE solving, the steps are always the same. You Laplace transform, you try to get big ass y by itself, then you use partial fraction decomposition if you need to, right? Sorry, yes.
What's the first translation point?
So that's the one where remind me, what's the Laplace transform of t?
Squared.
Yeah. So the neat thing, real quick, the Laplace transform of 1 is 1 over s. Do you see how the degree of s is just 1 ahead of the degree of what I transformed?
Yeah.
Constant, so a 0 power goes to a first power on the s, a first power on the t goes to a second power on the s, right? And again, I'm not making you memorize them anyway, but there are ways to memorize it. So what's the Laplace transform of e to the negative 3t? Careful.
Plus there's
Yeah, so it's a true translation, right? So back in the day, square root of x minus 1 would translate to the right one, correct? So this one, I want to translate to the left 3, so it's s plus 3. That's it. That's the translation theorem. That is it. So if you cover, like fallout, if you cover the e to the negative 3t, the Laplace of t is 1 over s squared. The e to the stuff just tells you how to translate that. So what's the Laplace transform of cosine? Let's say cosine 3t. The way I remember that, and again, you don't have to memorize these, but the way I remember it is cosine's the one that's got s on the top.
Yeah.
Because sine starts with s, it doesn't have an s on the top. So it'd be s over.
S squared plus 9.
Yeah, so what's the Laplace transform of e to the 5t cosine 3t? Jeff. Don't look at the monitor, Jeff. Oh, sorry. S minus 5 over s minus 5 squared. Yeah. So you're just translating the s by 5 to the right. Is that right? Okay. Maybe. You guys right? Yeah, the most interesting ways to do this. Huh?
I'm so glad you did this.
Yes.
So we look at the one that's like not gonna be e with something, we get its base, get all the s's, and then we replace the s's with whatever.
Yeah, totally. Yeah, that's exactly what you do. So if you had to think about this, you start with this, and then you could do exactly this, right? Yeah, that's it. So the first translation theorem, it needs to make immediate sense because in the Laplace transform there's an e to the negative st, yes? So all this adds in there is e to the at, which just shifts the s from s to s minus a. That's why this becomes the translation. That's why it becomes s minus whatever the a is. It's almost too nice to believe. I can tell some of you guys are like, whatever you say. Let me go to Christian again. I was saying that before.
So I'm looking at number 5 for the answer. Where did the 1 happen? Because I
Oh, let's see. Number 5.
Yeah.
All right.
I have the similar answer as the
Where am I at? Let's see.
So the 1/2 t squared. So I got 5t power t. I just didn't get the 1/2.
Oh, let's see.
It has to be t squared power t.
Let me remember what I was thinking. Oh, okay. You ready? Okay. Help me out. Okay, here's the way to kind of go backwards. So guys, what is the Laplace inverse of 1 over s cubed? What's missing? So look at your sheet if you don't remember. So it's something over s to the n plus 1, right?
It's factorial.
It's n factorial, correct?
Yeah.
Pretend like that. Yeah, that's okay. Okay, everybody with me? That's a 3. So what's n? 2. So what should be on the top? 2. Do you see that? Is that right? So really, it's just doing this. Sort of like any integral. If I'm supposed to have a 2 up top, I can put a 1/2 outside and a 2, and so I can even put it outside if I want to because it's just an integral. In this case, it's sort of a weird derivative, but still it's linear. I need you guys to understand. So if I know this is a third power, I know that n is 2, then I know the top is supposed to be 2. It's a 1 though, so I need to put a 1/2 to make a 2 show up. So read with me. Now it's also translated, but that almost doesn't matter because I just showed you how to do it. So it'll be 1/2. If you translate this back, it'll be 1 over t squared, right? I'm sorry, not 1 over t squared. T squared. And then you apply the translation. So that is just because of this. So if it was that, it would be this, and then that is because it's been translated by 1. So let's do a problem like that. Let's see. What if I had to do... there. I want to not lose your pen here. Let's see. Yeah. Okay, so what's happening in this thing? What's K? 2. Is there an S up top? So it's a cosine then, right? What should be up top? For cosine, what should be on the top? Yeah, it should be a 2. It should be K, yes? It's K over S squared plus K squared. Is there a 2 on top? No, damn it. But what do? I take the 3 out. And how do I get a 2 to show up? Yeah, so what's been prepping you for this moment? All of calculus. So when the constant isn't what you want it to be, you can force it to be what you want it to be. The Laplacian and the inverse Laplacian are linear, just like integration is. Meaning you can take stuff out, put stuff in. So if you cover this, that would be what? So I get 3/2. What would this be? Cosine. 2t. E to the negative t. Yeah. So normally I put the e in front, but you can kind of do that for yourself. The translation piece, don't care about it at first. That's cosine. The translation is just going to add e to whatever the hell the opposite of that is. Is that all right? You've done stuff similar to this. This is just a repackaging of that math. Yeah.
Why isn't it sine of 2t? Because doesn't cosine have the s on
Oh,
top?
cosine has the s up top, yeah. Oh. Listen to me. I had a whole thing about how to memorize this. Sine has the k up top. Cosine has the s up top. Thank you. So it should be sine. Okay. But the nice thing is you don't have to have them memorized. Yeah. Like I thought I did. Apparently I don't. So like so many things, I ignore a piece of it for a moment, get the form of the answer, and then I could just throw in what corresponds to this translation. Yeah, this is from before, I think. I always forget to erase stuff I put up here. Okay. So, it's understandable if the power series sections have been kind of overwhelming you. So maybe some of you guys haven't fully gotten into the Laplacian stuff yet. Is that possible?
Yeah.
I've gotten very little homework, so I'm thinking everybody's sort of like plowing their way through. Okay. In general, what I always try to tell students is, I can't remember if I had this discussion with you guys, make homework your own. Meaning, I've assigned problems. There's many problems and the type of problems I think you need to do to really get to know something. You go, that's nice, Jeff. I got shit. I got stuff going on. So what you do is, you make sure you do problems from every damn section, so you get practice from every idea, but maybe you don't do every problem. Maybe you do every other problem. You with me? Now, am I saying I'm going to be cool with that?
No, I'm gonna be like, finish this, what the hell? I'm probably not gonna say what the hell, that would be a little weird. You guys kind of with me? But as a student, what's more important? Finishing every homework problem or getting ready for the test? Getting ready for the test. I understand that doing every homework problem is one of the better ways to get ready for a test, but I think I've discussed this with you. I had 3 jobs in college. I never finished homework. Are you kidding me? I never finished homework. Holy shit. So I just did as much as I could to get ready for it. I kicked ass on the test. I sucked on the homework and projects. Forget that shit. I had no time. You guys got with me? So I like to say my report card had a lot of personality. But you know, I didn't have anybody to pick my way. I had to work my ass off. So I understand you guys have similar things going on. Maybe it's not jobs, maybe it's family obligations, whatever. But you have to do practice. And you can't come to the test with entire sections not looked at. You're going to die on these problems. So if you're doing that, if there's sections you haven't looked at, start doing every other problem, right? Do some from every section. I'm still going to finish this. You're still going to get half credit. Who cares? The tests are the heaviest weighted things. Okay, maybe? Okay. I can't remember what I told you that one semester, the second semester I ever taught, I made homework worth nothing. Nobody did the homework. They all failed the first time. And I was like, okay. Shit. So then I redid the syllabus. I'm like, I'm going to make homework too. Because it's human. If I have 5 classes that have homework and my class doesn't, guess what? I'm not doing anything. I'm not doing any damn homework because there's other things. It's human, so I got to make it worth something. Something I never tell students early is homework is 5% of your grade. Homework is 5% of your grade. How do I trick you? Because I put it together with quizzes, and that's 15 or 20, right? Why do I trick you? Because I have to. Because if I make it worth nothing, nobody does it. If I make it worth too much, the people that get homework answers from other locations get a really high homework grade, which allows you to fail every test and still pass. And that I'm not going to stand for. Screw that shit. So I make homework worth something, but not enough and not too little. Not too much, not too little. Anyway, sorry. That's all side note. So you have YouTube, you have study guides, you have all kinds of shit. Yes?
I was gonna see if you go
Which one?
40 and 702.
40? 40? Oh.
Yeah.
40 and 7.2.
Yeah, so use your time. I just tried doing it all, but I didn't do that.
This year?
Yeah, you have to do like 3 partial fractions.
This one?
Yeah.
Yeah, okay. So it sounds like you've done some of the problem, yeah. So some of these are going to become very heavy on the partial fraction stuff.
Okay.
Yeah.
I just wanted to make sure I was doing it right.
Now, I wouldn't look at this and know that's going to happen, to be honest.
Yeah.
But it sounds like once you do some, I'd go to any problem like this assuming there's going to be some kind of partial fraction stuff.
Yeah, all the last ones have all.
You guys kind of with me? Do you want to do some of this, or does that answer that?
No, that answers that question. I was
Okay.
making sure I had to do for each. 'Cause I
Has
got-
anyone else tried that problem yet? I know some of you guys are on WebAssign, so you're not even sure if you're doing this problem. By the way, real quick, WebAssign does not make every problem available to me. So sometimes it's 40, but I'll assign 39 in WebAssign because they don't even offer 40 for me to pick. But you're doing the same kind of problems. So very often you'll do a problem that doesn't look like anything that the book has just because it was offset. You're still doing the same kind of problem. Sometimes it works out in your favor. Sometimes it doesn't. Yes?
I have a more conceptual question, but specific to one of the homework problems. This was on homework 6.2, number 15, and it has to do with getting the constants. And normally you get like C2 in terms of like, I don't know, C0. But in this problem, I ended up getting C2 in terms of C0 and C1.
Oh.
And I have no idea how to like split that up.
The neat thing then is you're going to get 2 series that both have like an X term or something. So guys,
I'm not even sure if that happens here, but this could happen, and I'm not saying it. Your standard power series problem, you get C0, and normally it goes with like 1 x squared, x to the 4th. You guys with me? And then your C1s go, one of them, go with x cubed, like your even and odd powers. Is everybody sort of? It is very possible to get a problem where you get two series that have the same x's, just different coefficients. So you could have one that's like 1 plus a half x plus 2/3 x squared plus, and the other one is, x plus 5/6 x squared plus whatever. Does that kind of make sense?
Yeah.
So that sounds like that's the way that's headed.
Oh, I see.
Does that help?
That would work.
Yeah, okay. I love you guys so much. I'm always so hopeful for you. The homework, there are certain problems in the homework that go like an extra step. And I'm gonna always do that because I wanna push you a little bit, right? That's one of them. I can't remember if it happened in another one, but I remember one of them did that. So what, does everybody understand Ian's question? He gets C2 equals like C0 plus C1 or whatever, which means when you plug it in, you're going to be able to pull apart the C0 and C1 pieces. So it's going to go, that's why you're going to end up with an x term in each power series, an x squared term in each power series, instead of they kind of like take turns. Okay, maybe, okay. Does that make, okay, some of you guys are going, oh, okay. So if you haven't done the problem yet, that's what's going to happen on that one. Yes?
So you can still split them apart into two different wides, right? Like
Totally.
with this one, basically what happens is you get two fractions of C1 and C0. That's what I got over another fraction.
Yeah. So you pull out C0 and put it in the Y1 or whatever you call it, and you pull out the C1.
Okay, it works.
So they're going to share the same power on the x, just different coefficients.
Oh, okay.
Yeah. I like it. What is the, all right, real quick. Does anyone remember the power series for e to the x?
Yeah.
Bless you. What's the power series for e to the x? 1 plus Yeah, good. X cubed over 6. So yeah, x to the n. So if I have one answer is e to the 2x and one answer is e to the negative 3x, and we have seen that, correct? And I do a power series, shouldn't I get both power series with all of these terms? Does that make sense? Okay, so that's all that's happening there is, I don't know if that really makes sense to everybody. So your standard power series problem we've seen, 1y is 1 plus x squared plus x to the 4th, right? With whatever coefficients. The other one is x plus x cubed. We see a lot of sharing. One gets the even powers and one gets the odd powers. That doesn't have to always happen. In fact, we've seen those answers before. Therefore, if I did a power series, I should get two series with both. That is very possible, depending on the way I kind of would do it. Maybe. Okay, so it sounds like that happens at least once in the homework. Okay. Anything else? By the way, the actual test is not going to be quite this long. I just want to give you a lot of things to practice, right? So as I was doing the answer key, I was like, damn. But just realize the actual test will not be this long. You're not going to have that much time. Yeah.
Any questions?
I don't know. This one has. Yeah, I'd say like 11 questions, maybe 12. Yeah. So you're going to have problems that relate to every idea on here. There's obviously going to have to be some stuff I kind of like chuck. And then I could put some stuff in bonus. So which problems exactly will I decide not to put on the test? You will find out on the test. Could be any of this. Andrew? So I'd be surprised if you haven't. No? You guys are like, nah, I like Steve. So, again, the nice thing is I'm not gonna make you memorize the Laplace stuff. So hopefully that helps out a bit. That takes some pressure off. I never make you memorize stuff I don't have memorized. I used to have them memorized, and now I kind of forgot some of it, so I'm like, I'm not gonna make you memorize. What else can I say? Let's see. I like 7C. That's gross, but we've seen stuff like this before. Where, right, and if you look at the answer key, you can see what I did, but it's this idea of if I can make that a perfect square, then I can make it fall into a certain form. Then it's just a translation, correct? So whenever you see like an inverse Laplace of something where the bottom's not factorable and it's a quadratic, you think that. You think, can I make it into a perfect square, like a completed square kind of idea, plus whatever shit makes the bottom work? Then it's just going to be a translation. Does that make sense? Yeah. Okay. Those are the kind of things you look for. You've done that before in some integrals in Math 180, for example. Well, depending on the future. So I will have a couple problems that are just basic, straight up Laplace. And then there's going to be a couple problems where you have to solve differential equation using Laplace transforms. These are both the same, except this one involves a translation, of course, right? But they're really the same problem, same kind of problem. Okay, I'm not sure what else to do for you. So you know my office hours. If you're tired of listening to me talk, I don't blame you. I talk a lot. I'm sorry. If you haven't tried to yet, go to YouTube and search Laplace first translation theorem. Watch some videos, go, this guy's shit, this lady doesn't make sense, oh, this person makes sense. Go to their channel, see what else they got, right? That's a beautiful thing you guys can do now. Tears. Okay. Oh, by the way, does anyone look for the last video? I forgot to say something. I don't even know if anybody, I think some people watch the videos, unless it's people from other countries watching the videos. The view count's going up, so. It didn't record it from last time for some reason, I'm very sorry. So if you're looking for that video, it doesn't exist. I'm sorry. Technical difficulties happen. That's it. If you no more questions, go ahead. It's about time anyway. So I'm around. I'll help you out. Or same thing as always. So I'm in there from 1 to 12 right now. Yeah. And then I go to a classroom at 12. My class starts at 12. Okay. Yeah. Anybody else not get their quiz?